Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 3 from the International A-Level Edexcel Mechanics M1 October 2022 paper. And this question here is about this particle which is on a rough plane which is inclined to the horizontal at an angle of alpha, where tan alpha is 3/4. The particle P has a mass of 2 kilograms and it's held in equilibrium on the plane by a horizontal force of magnitude x newtons, as shown in figure 2. The force acts in a vertical plane which contains a line of greatest slope of the inclined plane. So we got to show that when x equals 14.7 there is no frictional force acting on P. Alright, so now what I've done is I've got a little copy of the diagram below. Now the first thing I like to do in these type of questions, to make it easier for me to resolve the forces and to be able to see everything, I personally like to do this, and of course you don't have to do this, but I personally like to redraw this force, but like this, after the object rather than before the object. And when I redraw it, I'll just redraw it like that, so I won't have, you know, let me just make that a bit bigger. I won't have this over there, x newtons. I'll move the x newtons on the other side over there. So this will go. Alright, and I'm just drawing the same force, but just on the other side, just to make it that little bit easier when I'm resolving. So this is x newtons over here. Okay, it has a mass of 2 kilograms. Now the weight, therefore, I changed that to y, didn't I? The weight, therefore, will basically act straight down. Okay, and it's going to be 2g newtons. 2 times g newtons. G standing for 9.8, the acceleration due to gravity. As we know, W equals mg. Alright, so that's the force acting downwards. Okay, now, that's the weight. So those are the two forces acting on it. Now it says show that when x equals 14.7, there is no frictional force acting on P. Okay, so basically they're saying that when that force is at particular value, there will be no frictional force acting. Okay, and we know that this is a rough plane. When we have a rough plane, of course, frictional force, we know there is a frictional force. But in this particular case, when x is this value, it's saying that there's not going to be any frictional force. Okay, so how do we understand that? Okay, let me just explain by way of the basics. Yeah, supposing you have a block. Okay, you have a block which is just resting on a rough plane. And you have no force acting to try to push it in any direction. Okay, so there's no force acting in this direction. You'll just have its weight. There will be no frictional force because the resultant force acting on this thing is 0. Okay, before even you consider any friction, there's no force acting on it. Okay, there's nothing pushing it this way here. And this way you have the weight, you have the reaction force, okay, acting directly upwards. Okay, but you don't have any force acting in this direction, so there's no friction. If you start to try to push it, if you put a force over here, okay, or you could start to pull it, you could say, right? You have a force over there pulling it. Okay, then friction will start. If it's a rough plane, then friction will come in to try to oppose that value. So whatever that value is, friction will increase to match that value until friction cannot match it anymore, and we're left with this friction reaching its limiting value. So then if this force goes more than the limiting value of friction, then the thing will start accelerating, right? But in the case where nothing's pushing it, i.e. the resultant force acting on it is 0, then there will be no friction. So if I have a force pulling this way and have another force pulling this way, and they're both equal to each other, if they're both equal to each other, then therefore the frictional force is going to be 0 because there's no resultant force. It's not trying to move. Okay, but if P was greater than x, then the friction will act in the direction to try to match what that force is which is moving. It tries to stop the motion. So we have a similar type of situation here. We have the forces acting on this are these two forces, and of course you have the reaction force, which is always perpendicular to the plane. It's always perpendicular to the plane. Okay, so you have the reaction force acting up here. Okay, but if we consider the forces parallel to the plane, Okay, if we consider the forces parallel to the plane, Okay, we want to find the situation. Okay, we need the situation where the resultant force is equal to 0, okay, parallel to the plane. That's what we need. If the resultant force, okay, without considering friction, is equal to 0 parallel to the plane, then we've got the situation where friction will be 0. So how do we do that? We have to resolve the forces parallel to the plane. So let's think about these forces parallel to the plane. So we have here the component of the weight perpendicular to the plane and also parallel to the plane, and the component of this x perpendicular to the plane and also parallel to the plane. Okay, so now we know this angle is alpha, and we've discussed before why is this angle is the same as that angle. It's to do with similarity between this big triangle here and this small triangle here. This big triangle here has a right angle in this corner. This little triangle here has a right angle in this corner. This big triangle here has this angle here as part of it. This little triangle also has this angle here as part of it. So they both have a right angle and this angle in them. Therefore, the third angles must be the same. Similarity. So this angle is alpha, and we know because this is horizontal and this is the angle of the plane, these two angles are corresponding. So this angle here is also alpha, right? So if I want to resolve this x newtons force parallel to the plane, I've got to go into the angle. So I'm going to use cosine alpha, x cosine alpha. Okay, I can think of it, I'm looking for the adjacent side. Okay, and when I'm resolving it perpendicular to the plane, okay, I have to go away from the angle. I have to find this side. I can think of that as I'm resolving it, so I'm looking for the opposite side. So that's x times the sine of alpha. And here we have 2g going into the angle. In this case, it will be 2g cosine alpha, because we're looking for the adjacent side in this case. Here's the angle going into the angle, and this is 2g times the sine of alpha. Those are the components of these forces, horizontal and parallel and perpendicular to the plane. So I don't think we need to worry about the perpendicular to the plane here, because we're looking for the situation where the friction is 0. So let's just look at the forces parallel to the plane. Okay, so it doesn't matter which way we take as positive. I've just taken up as positive. We'll say x times cosine alpha must be equal to 2g sine alpha, okay, for us to have this situation where the friction is 0, equals 2g sine alpha. Okay, so we need the situation where the resultant force is equal to 0, parallel to the plane. Okay, therefore the friction is going to be 0. Okay, this is the resultant force, and that's friction. Okay, so now the next thing we need to do is find what alpha is to help us to sort this problem out. Now it's always best to take alpha as its exact, and don't take it as the angle, but the sine and cosine of the angle. So I'm going to draw a little triangle here. I'm going to say, let's say that this angle here is a right angle and this is alpha. Then the tan of alpha would be opposite over adjacent 3/4. So the hypotenuse is going to be 5, 3, 4, 5 triangle by Pythagoras. So therefore I can say the sine of alpha is opposite over hypotenuse, which is 3/5. And the cosine of alpha is adjacent over hypotenuse, which is 4/5. I don't need to know what the angle is. I need to know what the sine and the cosine of the angle are. So as we said, cosine is 4/5. So this is going to be 4/5x equals 2g times 3/5. So that's going to be 6/5, okay, g. All right, so we can say therefore x is equal to, multiply by 5, the 5 cancels out, you got 6/4, which is 3/2 times g newtons. So we can say x is equal to, we have 3 divided by 2 times 9.8, which gives us 14.7. X is equal to 14.7. Okay, x is already in newtons. It's already mentioned this in newtons, so I don't have to write the n here. Okay, it says x newton. So x is 14.7. Okay, show that x equals 14.7, and that's what we've shown. So we have shown, we can make a little statement because they already gave us a value. It's better for us to make it clear. So we can say when x equals 14.7, okay, the frictional force is 0. Okay, we can see that very clearly, right? So we made F equals 0, so we ignored the frictional force, and therefore that's when the upward force and downward force, they balance each other out. Because they balance each other out and it's parallel to the plane, there's no friction acting because this thing is not tending to move. There's nothing pushing it upwards or pushing it downwards. If there was a resultant force, then the friction would act to match the side, or to help the side which is stopping the movement. So for example, if this was higher, the friction would act in this way to stop it. And if this was higher, friction would act in that way to stop it, until friction can't actually go any higher than that particular value, and then it will start to slide down, all right? Or start to slide up, depending. So that's what we have to understand here in this question. A few important points. Now, one of the important points here is also to try not to use the angle, use the sine and cosine of the angle. You'll have more exact values. It will make your life a lot better and easier to deal with this type of situation. So there's part A. Now for part B. It says the coefficient of friction between P and the plane is 0.5. So mu is equal to 0.5. Okay, find the smallest possible value of x. So this time, it's a new situation now. X is not what it was before. It's now a different value. We're going to find the smallest possible value that x can be, such that this thing, of course, is still not moving. Okay? All right? It's held in equilibrium. Okay, so we assume the same thing. It's in equilibrium, so it's not moving. Okay, I'm going to do the same thing with this force. I'm going to draw it in this direction. And I'm going to get rid of it from there, just to, I just think that makes life a bit easier, that's all. Make this a bit bigger. It makes life a bit easier. So I'm taking out this, just drawing on the other side. I prefer to do that myself. As I said, it's up to you what you guys do, but this is what I like to do. Okay, so this is x newtons. This is the weight, which is 2g newtons. Okay, and it says find the smallest possible value of x. Right, so you have the reaction force acting, which is going to be important this time. Last time we didn't really use it. Okay, now this is where you have to think a little bit. The smallest possible value of x, such that this thing is still in equilibrium. This thing is in equilibrium. It's not sliding up nor down. Okay, now if you want to find the smallest possible value of x, that means you got to find the value of x that will be just enough to stop it from sliding down the plane. If you want to find the biggest possible value of x, with the value of x that is the highest it can go before this starts sliding up the plane. Because if you start pulling this with a bigger force, it's going to try to slide up the plane. But the friction will stop it until a certain point. And a lesser force is required to stop it from sliding down the plane. Because if you didn't have the x there, you know, the frictional force would act to stop it from going down the plane. Right, it might not be enough, so you know you have this other force x acting to stop it from sliding down the plane. That value of x is going to be less than the force required to make it slide up the plane. To just stop it falling down the plane, less force is required than to actually pull it up the plane. So we have to look at the situation where this is P is on the point of sliding down the plane. On the point of sliding down the plane. That's when x is a minimum. X is a minimum when P is on the point of sliding down the plane. Okay, so therefore we have to show therefore the friction is equal to F max. It's equal to its maximum value because it's on the point of sliding. It's just about to slide, so it's reached its limiting value, and it is acting in the opposite direction to where this is about to start to slide, which is acting up the plane. The friction is acting up the plane. Okay, so the friction is reached F max and it's acting in this direction. So this is now F max. I'll put it FM. That's been achieved because it's on the point of sliding up the. It's on the point of sliding down the plane. So F max is acting upwards. Okay, it's opposing that motion. All right. So now let's resolve the forces perpendicular to the plane first. Now again we have our same situation as last time. I'll just do it over again. Okay, so we have the reaction force. Let me do it with some dotted lines here. The reaction force perpendicular to the plane. Sorry, so not direction. The weight perpendicular to the plane and parallel to the plane. You have the frictional force, which is already parallel to the plane. Then you have the x perpendicular and parallel to the plane. Again, the same situation. This is theta. This is alpha. Sorry, this is alpha. So here we have x times cosine alpha, as we discussed before, x times sine alpha, and this is going to be 2g times cosine alpha and 2g times sine alpha. So if we resolve the forces perpendicular to the plane, then you have r is equal to 2g cosine alpha plus x sine alpha. And we worked out already that the sine of alpha was 3 over 5, and the cosine of alpha was 4 over 5. Okay, because the tan was 3 over 4. That's right, opposite. That's good. All right, so now that's resolving perpendicular to the plane. Now what we can do here is we can, I'll do things in terms of g for now. So we say, therefore, we can say r is equal to, we have cosine alpha, which we said was 4/5, so that's going to be 8 over 5g plus, and sine alpha, as we said, was 3/5, so that's 3 over 5x. Okay, so that's one equation. Then we can resolve parallel to the plane. Now it's on the point of sliding down the plane, so I'm going to take down as positive. Okay, so I'll say 2g sine alpha. Okay, and you're going to have equals, because it's still in equilibrium, you have x times cosine alpha plus f max. Okay, now we know that f max is equal to mu times r, right? So we can say f max is equal to, now mu we know is 0.5, so it's 0.5, which is a half, times 8 over 5g plus 3 over 5x. So we can say f max therefore is equal to, that's going to be 8 over 10g plus 3 over 10x. In fact, we can just call this 4 over 5g for now. That simplifies, doesn't it? 4 over 5g plus 3 over 10x. That's f max. So that's what f max is. So I have 2g times sine alpha. As I said, sine alpha is 3/5. So that's 2 times 3, that's 6 over 5 times g equals x times cosine alpha, and cosine alpha is 4/5, so that's 4/5 x. Okay, plus f max, which we have here as 4/5, 4 over 5g. 4 over 5g plus 3 over 10x. So now if we rearrange this, we have 6 over 5g minus 4 over 5g, which is 2 over 5g, is equal to 4 over 5x plus 3 over 10x. That's like 8 over 10. That's going to be 11x over 10. So therefore I can say x, let me do it down here. Therefore x is equal to, I can cancel this with this, gives me 2 and 1. So x is equal to 4 over 11g. So that's x equals 4 over 11g. That's one way of writing my answer, and you can, it's perfectly acceptable to leave your answer in terms of g. That's perfectly fine. That can be done. All right, that's one thing you can do. Okay, we can also write the answer to 3SF. Okay, so we have 4 over 11 times 9.8. Okay, which is 3.56. So you can write it as 3.56. Okay, or if you want, we can write it to 2SF, which will be 3.6. Okay, all of these are acceptable answers. All of them. I mean, technically correct is this one, because G, we use it as 9.8. So 3.6 and 4 over 11G are technically the correct answers, but they accept 3SF. And I would always advise to leave it in terms of 3SF or in terms of G if possible, because those are acceptable for all different types of answers, even when you use G and you don't use G. 2SF is only acceptable if you've used G in your calculation. If you haven't used G, then you should, if you haven't used G as 9.8, which you're supposed to do if you're going to use it as a decimal, then you haven't had to use G in your calculation, then 3SF is what you should write. Okay, so that's always the safest bet, either in terms of G or 3SF in your exam. Okay, so that concludes this question. I hope that was very clear. If the question said find the largest possible value of x, we would have this on the point of sliding up the plane, in which case F max would be acting down. So the difference here would be in this part, F max would be on this side. Okay, and the value of x would then be larger, of course. Right, so that's something you have to take into account. So when it says the smallest possible value of x, it means, you know, that's the smallest value of x is going to be the value of x that just stops it from sliding down, so friction's acting up. And the largest possible value of x, such that it stays in equilibrium, is the value of x that causes it to just about be sliding up, therefore friction acts downwards. Now that's a very important point, and I think that was not very understood very well in this question by many students, as is mentioned in the examining board. So it's something that we have to take into account. And the other thing they mentioned is this thing I mentioned about having exact values for your sine and cosine of alpha. It's always useful to leave them in this fraction form. All right, so that's the answer to question number 3, part A and B. Other questions from this paper can be found in the playlist that's going to appear in this region here on the screen. Other questions from this topic of statics and friction can be found in the playlist over here. And you can subscribe to my channel by clicking on this link in the middle. Thank you for watching and see you soon.